So class, for question 13, we are given figure 6.9 whereby we have a light string. We move around a 2 kg pulley which is attached to a 5 kg load. So the height of the load is 2.5 meter above the floor. So when the load is released, we will find out that the pulley start to rotate. So the pulley is doing rotational motion and the load will descend to the floor. So the load is doing linear motion. So the load is doing linear motion and our pulley is doing rotational motion. Okay, how come the pulley have rotational motions? Because we attach a string, so the string have tension, and this tension have a distance r from the center or the axis of rotations, so it will rotate the it will rotate the pulley, and then the loads will accelerate downwards. So given the moment of inertia for the pulley can be calculated using equation I is half mr squared. We want to determine the speed of the load just before it hit the floor. So as the load strike on the floor, as it strike on the floor, we want to find what is the speed of the load. So class, in order to find the speed of the loads, we must know the acceleration of the load. So we must know how fast the load accelerate downwards. Then we can determine the speed of the load. So in other words, in order to solve question A, I need to determine the acceleration first before we can determine the speed of the load just before it hit the floor. So first I can consider the rotational motion of the pulley. So I apply Newton's second law, summation torque, the net torque that exert on the pulley will produce angular acceleration for the pulley. So the force that create the torque is the tension in the string. So the tension in the string which have a distance r from the axis of rotation create torque. So we have R multiplied the force is tension. So the tension is applied tangential to the pulley. So the angle between the R and the force tension is 90 degrees. So this one will equal to the moment of inertia for the pulley can be calculated using equation half mr squared. So I put it down half mr squared, and the alpha, I'm not going to determine the angular accelerations. So again, we recall, we can relate the angular acceleration with the linear acceleration, whereby A is R alpha. So I put it down here. So I rearrange, the alpha will be A over R. So the R here refer to the radius of the pulley lah, capital R. So I put in the value. Okay, so the radius is not given, so doesn't matter. We see whether we can cancel it. So I'll get this R and R will be the same, so I put it with the same symbol. So R. So R and R can be cancelled. So ni R cancel satu, sini tinggal R. So sini ada R, sini pun ada R, dia akan saling cancel. So last teacher will get T equal to half. M is how much? M is, okay, our M is 2 kg. So I put it in half 2A. So last I get T equal to A. So this will be my first equation. Then I consider the linear motion of the load. So I have summation force equal to MA, Newton's second law for linear motion. So for the load, the mass, I have tension upward and I have weight downwards, and this load is accelerate downwards. So taking the direction of acceleration as positive, so I'm going to have weight minus tension equal to MA. So the weight will be mg minus tension equal to MA. So the mass of the load is how much? Okay, the load is 5 kg. Be careful. So the mass here will be 5. The mass of the load, G is 9.81 minus tension equal to 5A. So I'm going to have, okay, let me calculate. 5 times 9.81 is around 49.05. 49.05 will be 5A plus T. So this is my second equation. So I put 1 into 2, okay, because the tension equal to A from equation 1, I know that T equal to A, so I can put it into equation 2, so I have 49.05 equal to 5A plus A. So I'm going to have 6A equal to 49.05, so I get the acceleration is around, so 49.05 divided by 6. So I get my acceleration for the load is 8.175 meter per second. Okay, so the load is doing linear motion. The load is performing linear motion. So consider the linear motion. So I already know about the acceleration. 8.175 meter per second squared. Then I want to find the final speed of the load as it hit on the floor. So if you refer back to the questions, very starting, your load have a height of 2.5 meter. So when it strike on the ground, as it hit the floor, strike on the floor, we understood it have undergoes a distance or displacement of 2.5 meter. So before release, we understood the load is at rest, so the initial velocity is 0. So now I can determine the final speed of the load just before it hit the floor by using equation, kinematic equation. V squared is u squared plus 2as. So this one is 0, so I have 2 times 8.175 and the displacement is 2.5. So I'll get the speed or the final velocity of the load just before it hit the floor will be, let's calculate, 2 times 8.175 times 2.5, so I get 40.875 square root. So I get my answer is 6.39 meter per second. So this will be our answer for question A. Then question B, if the string suddenly snaps while the load is 1.5 meter above the floor, explain qualitatively why the load would hit the floor with higher speed than that of A. So, why when the string suddenly snaps, then the load will going to hit the floor with higher speed. So we understood that when the string snap means what? Putus, break, putus. So what happened? Our tension becomes zero. So we will understood that now the load will fall freely. Okay, so now the load will going to fall freely in the air, whereby our acceleration will equal to the acceleration due to gravity, which is 9.81 meter per second squared. So this value is greater than the acceleration of the load when it is attached to the string, which is 8.175 that we calculate just now. So it means that it would hit the floor with higher speed. Sebab dia sekarang bila tali putus, dia jatuh bebas. So bila jatuh bebas, dia rasa tarikan graviti. Nilai tarikan graviti ni 9.81 adalah lebih besar daripada acceleration bila load tu attach kepada string. So bila dia jatuh dengan acceleration yang lebih besar, maksudnya dia akan ada final velocity when it hit the floor, which is greater, yang lebih besar lah. So this will be our answer for question B. Okay? Just kecilkan so that you can see the whole question punya solution.